There is an unexpected issue with long-duration spaceflight. Astronauts risk losing vision. My name is Professor Sinclair. I work as a researcher at the Institute of Metabolism and Systems Research at the University of Birmingham, where I run a translational research group looking at brain pressure. I also work as a doctor, a neurology consultant, where we run one of the largest clinics in the world specialising in brain pressure dynamics. The focus of this project is spaceflight neuroocular syndrome, SANS. And it affects nearly all astronauts who have been in space for greater than 3 months. Now, this is a major concern because it causes fluid to build up or swelling around the eye nerve, the optic nerve, and also around the brain. And ultimately, this can risk visual loss or damage to these structures. Now, the problem is that we don't have an effective treatment. SANS gets worse the longer the duration of spaceflight, so this is a real problem when we're trying to think about missions that extend beyond the moon and further out into space. So our research project will look at how we can identify really early the signs of SANS and then monitor this using eye scanning. Then we'll look at how we can treat SANS, and we'll do this using a GLP-1 receptor agonist, which is work developed in our lab designed to help reduce brain pressure, reduce fluid in the brain, reduce fluid around the optic nerve, and therefore protect these structures from damage. Ultimately, this research project will hope to deliver a new treatment for SANS that will enable safe, long-term space exploration to Mars and beyond. So I want to introduce my colleague and co-investigator, Miss Susan Mollen, who is an ophthalmic consultant at University Hospital Birmingham and the Director of Ophthalmic Research. Miss Mollen, why is it important to scan the nerve at the back of the eye for this research project?
Imaging the eye nerve is incredibly important, as this can be the first sign of raised intracranial pressure and a condition called papilledema. These special eye scans, OCT, can diagnose this extremely early, and also what our research has shown can predict brain pressure. This study is going to benefit astronauts, as we have one of these platforms on the International Space Station, and the astronauts have been performing these scans on themselves. But this is going to help our NHS patients and patients worldwide. Eye scans with OCT imaging is non-invasive and incredibly quick.
So this is the OCT machine. We use it in the NHS to take pictures of the nerve at the back of the eye. It's non-invasive and very, very rapid, and we can get really accurate images on any disease going on in the optic nerve. But it's also available on the International Space Station. This is a really quick scan because the astronauts have to be able to perform this on themselves whilst in microgravity, so whilst they're floating. So although we're focusing on a really rare cohort of patients, the astronauts that develop SANS, what we're learning about how to monitor the optic nerve with OCT, and what we're learning about how to control the fluid in the optic nerve with GLP-1 receptor agonists is very applicable to our terrestrial patients. So we run a very large clinic at University Hospital Birmingham dealing with a condition called idiopathic intracranial hypertension, which is another condition of fluid in the brain and around the eye nerve. So the things that we're learning with our space research will be very applicable to our patients back on Earth to guide us how to monitor them more appropriately and also how to treat them more appropriately.